Hello class, my name is Tori Mills and I'm honored to be your Foundations of Algebra teacher this year. What we're going to start with our initial lesson is the real number system and its subsets. So let's look at our learning objectives for this particular video first. Here are our learning objectives. Students will be able to, you notice that acronym there, SWBAT. I'll use that a lot for learning objectives just for space. So students will be able to describe the real number system and its subsets. Students will be able to describe the relationship between the subsets of the real number system. And lastly, students will be able to name all the sets to which a number belongs given that number. So what is the real number system? The real number system is composed of all numbers that can be expressed on the number line. The real numbers are represented by a capital script R, and we see a number line here at the bottom of the screen. What is a subset? Another term that may have been unfamiliar in those learning objectives. A subset for our purposes is a set of values, or numbers in our case, that are contained in another larger set. For example, iPhones would be a subset of the larger set of cell phones. And another example, Nike shoes would be a subset of the larger set of tennis shoes. So what are the subsets of the real numbers? Okay, we'll start with the smallest subset and then move up from there to larger ones. The first one is the natural numbers or the counting numbers. The natural numbers are represented by a capital script N, and it's the set of all numbers. It starts 1, 2, 3, 4, 5, 6, going on in that pattern. So we say counting numbers because when I'm counting objects, I start with the number 1. The next subset of real numbers is the whole numbers. So the whole numbers are represented by a script capital W, and it's the set of numbers 0, 1, 2, 3, 4, 5, 6, and on in that fashion. You'll notice that it's very similar to the natural numbers. The difference between the natural numbers and the whole numbers is the whole at the front of the list. Whole numbers include 0, natural numbers do not. The next subset of real numbers are the integers. Integers are represented by a capital script Z. It's the set of numbers. Think about the whole numbers, which is 0, 1, 2, 3, on and on that way, with positive numbers and then their opposites. So you have 1 and -1, you have 2 and -2, you have 3 and -3, and it goes on in that pattern in both directions forever. The next subset is the rational numbers. Notice the word ratio, or the root word ratio in rational. It's represented by a capital script Q. Also, all fractions and decimals that end or have a repeated pattern are called rational numbers. We're going to provide another definition here as well. A rational number can be expressed as any number that can be written as a ratio or fraction of two integers. It cannot have 0 as the denominator. So examples of rational numbers would be 1/3, -0.67, and also the square root of 16, which we know is 4. The final subset of real numbers, the last one that we'll be discussing, are what we call irrational numbers. So irrational, IR, that root stands for not, so they're not rational. They cannot be written as a fraction. Think about what we said on the previous slide about the root word ratio. It's represented by a capital script I. These are decimals that never end and have no repeating pattern. So not just that they don't end, but they don't end and they don't have a repeating pattern. So examples of irrational numbers would be pi, the square root of 2, and negative the square root of 101. So how are the subsets organized within the real numbers? Okay, we're saying how do they connect? How are they interrelated? That was our second learning objective. And I think here, instead of just looking at a bunch of definitions, a picture would help a long way in that regard. So when we think about it, natural numbers are a smallest subset for real numbers. So the natural numbers is this small circle, and then what's the difference between natural and whole numbers? We said you add a 0. So whole numbers is a bigger group than natural numbers. Then inside, larger than the whole numbers, going bigger still, you have integers, and bigger than the integers are your rational numbers. Now notice you have this dividing line, and then you have irrational numbers over here on the right. Well, what does that mean? That means that a number cannot be rational and irrational at the same time. You will never have a number that is rational and irrational at the same time, because they're not nested inside of each other. They're written as two separate pieces. And we take the rational numbers and the irrational numbers, and we say together they make that umbrella that we call the real number system. Okay, so our real numbers is the largest umbrella. It has part which are the rational numbers, and they have pieces that go under it. And then we also have the irrational numbers there on the side. Let's look at one more visual to see how that's going to work. Now, this visual, the reason why I included it in the slide deck is because it actually gives you some of those sets and some of the definitions that we talked about, examples, so you can see what goes where. So you see the natural accounting numbers, whole numbers are all the natural numbers and zero, integers are all the whole numbers and their opposites, just meaning putting the negatives in front. For the larger than the integers are your rational numbers, which means it can be written as a fraction. And you see several things there, or a ratio. And then irrational, it cannot be written as a fraction. It's a non-terminating decimal with no pattern. And then we have examples listed here. So you'll see this in the puzzle piece, but we do want you to draw both of those graphs so you can start to really think about the relationship with these values and these definitions. So let's look at some problems. Name all the sets of numbers to which each number belongs. Let's start first with 30. Okay, so when we look at 30, we think about what sets is it going to belong to. So think about that. So 30, is it a natural number? Yes. Is it a whole number? Yes. Is it an integer? Yes. Can I write 30 as a fraction? 30 over 1. So yes. Is it irrational? No, it's not. And all of these numbers, everything inside of the box, will be classified as a real number. So 30 would be all of those except irrational. So let's take a look. Let's see it. That's it. Natural, whole, integer, rational, and real. So let's look at another example. The square root of 144 over -3. So for this particular one, we have to simplify the expression first. So the square root of 144 is 12. 12 divided by -3 is -4. So -4 is going to fit into what? It's not a natural number because it's negative. It's not a whole number, but it is an integer. It can be written as a rational, a ratio or a fraction, and it's a real number. So I think it's just those last three. All right, one other example here on the page, pi. Well, pi is not a natural number. It's not a whole number. It's not an integer. It's not rational. It is a real number, but what else is it? Since it's not rational, it's irrational. So it's going to be irrational and real. Okay. Now, the other type of problems that you may encounter, a few more examples. Give an example of a number that is a whole number, but not a natural number. Our answer there is 0. Okay. Now our next question, give an example of a rational number that's not an integer. Think about that for a moment. A sample answer would be 3.9. So a rational number that's not an integer, any decimal would do. So I could use 3.9, 9.3, 6.8. Lastly, give an example of a real number that's not rational. We have several sample answers, square root of 5, e, and pi. So these are some examples to get you started. Let's get to work on our practice, and then we will follow up with feedback on to the mastery check.